Good afternoon, all. This is WEEK-12 Microelectronics Device to Circuit Problem Solving Session. I'm Arpita Biswas, a PhD scholar in Electrical Engineering Department from IIT Jodhpur. This is more details about me that I did my MTech from IIT Jabalpur in Micro Nanoelectronics, and I did my BTech from Maulana Abul Kalam Azad University of Technology in Electronics and Communication Engineering. And this class schedule is every Tuesday, 7 to 9 p.m. So let's start the session. So this is the question one. The minimum number of MOS transistor required to make a dynamic RAM cell is the first option is 1, the second option is 2, the third option is 3, and the fourth option is 4. So go through the question carefully and try to get the answer.
Answer one, madam. One is enough for dynamic CMOS.
Okay. Can you little bit explain about it?
Yes, madam. Charging and discharging through one MOSFET is possible, madam. Output of a drain place, we can place one capacitor. We can verify the dynamic.
Yes. Good. This is the right answer. So the answer is the first option. Um, in DRAM, a capacitor is used to store a bit of data along with a MOSFET, which acts as a switch, right? So this is the word line, and here is the MOSFET, and this is the bit line. And here the capacitor is present, and this is connected with the ground. This capacitor is present, and this is ground. Okay. So let's move toward the second question. So this is the question number 2. If WL is a word line and BL is the bit line and SRAM cell is shown in, so carefully see the three circuit and try to get the answer. Where WL is represent the word line and BL is represent the bit line. Then SRAM, how you um, uh, defined?
Option three, madam.
Mm, Can you little
First
bit
is out.
explain?
Yeah, yes, madam. First stage output connected to the second stage input and second stage output connect to the first stage input. We are writing as well as reading the information from that particular location.
Why option 3? Why not option B? See the
Uh,
circuit
one,
carefully.
1 minute, madam. 1 minute. WL, BL, BL bar, VA, VB. Madam, second circuit, last circuit, both are PMOS. That is wrong, madam. Upper
Yes,
fill up network is PMOS and pull down network is NMOS. So
NMOS.
option two is the correct answer.
Yes, good. So option 2 is the correct answer. So when we are going to discuss, then let's know about the SRAM cell. Okay. So what is SRAM cell? Can you little bit explain about it? What is SRAM cell? What do you know about it?
Yeah, yes, madam. I know about this is about 60 RAM cell. Even RAM
Okay.
possible with 80 RAM. We are making for it is a back-to-back connection like multi-vibrator. Mm.
Hmm.
We are reading the data and we are writing the data. Whenever WL bar is 1, WL is 1, right line, then corresponding data will be stored on the respective back-to-back inverters.
Okay. So let's write down the point. So it can store the information as long as the power applied. The second point is random access means that in an array of SRAM cells, each cell can be real or written in any order. And next point is the structure consists of six transistors to store 1 bit information. And the last point is the main structure is formed by two cross-coupled inverters where the output of each inverter is fed input to the other inverter.
Madam, both SRAM and DRAM are volatile or only SRAM volatile?
Terms as- So here is the point that this is the NMOS and this is the PMOS, and for the third case the both are the PMOS. That's why the option B is the right answer. And here you can see that these two are the cross couple inverter. So where the output of the each inverter is fed input to the other inverters. So here uh, NMOS and PMOS are making the inverter where one of the output of the one inverter is fed to the input of the another inverter. Okay, but for the third case, both are the NMOS. So there are so from the fourth point you can see the right option is the option two. If there are
Madam,
any
can
other
you
student,
elaborate volatile and non-volatile, madam?
just a minute.
Hello, madam. Hello, madam.
Yes.
Yeah, thank you, madam. Volatile, both SRAM and DRAM both are volatile, madam.
Let me check. Just a minute.
Yeah, yes.
Actually, both. Can you little bit at first? Can you little bit explain about the volatile?
Yes, madam.
What you have
Yes, madam.
any idea about it?
Yes, madam.
Yes.
Volatile means when power gone, the information loses. When
Mhm.
power not, even power gone, also the information should be retained. That is non-volatile.
Okay, so in SRAM, this is the static. So if the power is gone, so in that time, if there is any information remaining, what you have any idea about it? Or in dynamic RAM, it is meant it's have an like memory, right? Right?
Yes, ma'am. Yes, ma'am. Yes,
So
ma'am.
what is the possibility for in that case?
Yeah,
Think logically.
in DRAM, up to certain time the capacitor retains the value
Hmm.
for a short duration. Even SRAM also for a short duration data will be stored at the output capacitance, madam.
Yeah. For the short terms, it means for both cases, na, it
Yes,
can
yes,
access a volatile memory.
correct,
Okay.
correct.
Yes, for short time it can access a volatile because for short time it can like the memory types, right?
Yes, ma'am.
Yes. So this is the question three. The circuit designer tends to define the size of the memory in term of dash, and the chip designer express the memory size in term of dash. So first option is bits and bytes, and the second option is words and lines. The third option is words and bit. The fourth option is none of the above.
Option C, I think so, madam. Circuit designer tends to define the size of memory in terms of words, and the chip designer expresses the memory size in terms of the bits.
Mm, okay, but you can recheck the answer. Okay, the right option
Right,
is the
right.
first one. The
Bits and
memory in term of bits, the first is
okay,
the bits, and the second
okay.
option is the byte. You can recheck the answer.
Yeah, chip designer maybe will tell in
Um,
terms of combination of 8 bits, that is bytes.
yes, which is byte,
Circuit designer in terms of bits. Okay,
bits.
madam. Circuit designer means element by element. Each MOSFET will be treated as one memory element, and the chip designer will treat that as a 8 bytes. Correct, madam. Understand.
So this is the question four. In the circuit shown, the clock frequency, that is the frequency of a clock signal, is 12 kilohertz. The frequency of the signal Q2 is dash kilohertz. So see the circuit carefully and try to give the answer.
It's a 2-bit counter, madam. Clock 12 gigahertz in the first flip flop followed by the second flip flop. First stage output Q1 bar, Q2 bar get connected to the AND. Um,
Take your time, you calculate it at first.
yes,
Then
yes, yes.
tell me the answer.
4 kilohertz, madam.
Can you little bit explain how you have calculated?
I am checking for one by one case, madam. Let us say
Mhm.
clock is, I am taking that as a positive clock. Let us assume D1 is 1, then Q1 will be 1, D2 will be 1, Q2 will also be 1, and Q2
Mhm.
bar 0, Q1 bar 0. Both we are connecting. Next cycle it will be 0. Uh, I am checking for 0, 0, 0, 1, 1, 0 like that, madam, for different input combinations.
Okay, then.
Delayed version. I'm not sure, but 4 kilohertz I am estimating.
Okay, let's
DRAM.
calculate it.
Yes, yes.
This is Q1, Q2, this is D1, D2. And this is Q1, the next level. And this is Q2, which is the next level. And now, at first, the clock, D1. Okay, just taken the input Q1 and Q2 0, 0. Then tell me what is the value of D1 and D2. If Q1 and Q2 is 0, in that case, what is the value of D1 and D2? Hello.
D1 1, D2 1, madam. Q1 bar
How
and
D
Q2 bar get connected to the D1. Na?
C Q1
You
is
are
directly connected to the D2.
D2. Yes, madam.
Then if Q1 is
Uh,
0, then what is the value of D2?
oh, then that will be 0. Q2 also 0.
Yes,
Q2 bar 1. Correct, madam. 1 0. 1 0.
yes, right? And
Yes,
then what will be the next level? Like
next.
Q1 plus and Q2 plus, what will be the value?
Yes, yes. Next data. Yes, madam. Q1 again 1. Q1 plus 1, 1.
Hmm.
Q2 plus 1 also 1, madam.
Q2 plus for D flip-flop, or if the D1 is 1, then next level in plus 1, if you are taking, but what is the value for D flip-flop? It also 1, na?
Yes, yes, yes.
You can also recheck it. So if D2 is 0, in that case
Then
Q2
Q2
plus
Q2
next
will be
level,
0. 0, 0.
yes, it will be the same. So next
Yes,
coming
yes.
to the clock 1, right?
Slack.
So you're
Yes, yes.
taking the next level. Now it is 1, 0. Now tell me what is the value of D1 and D2?
Uh, Q1 1 means D2 Q1 1 means D2 1 D2 1
D2 1 and D1 value?
D1 value 1 minute, madam. Q1
D1
bar
here,
0 0, madam, 0, madam, 0.
yes,
D1
0.
0.
And what is the value of Q1 plus and Q2 plus?
0 1 0 1.
0, 1. So next clock signal 2 is 0, 1. Now tell me what is the value of D1, D2.
Q1 0, so Q1 bar 1, then Q2 1, Q2 bar 0 1 0, madam, D1 0.
D1, 0.
Yes.
Okay. Uh,
Uh,
or what is the value
D2
of D2?
D2 D2 1, madam.
D2.
Sorry, madam.
Like
Q1
D2
0
is
na D 0 0,
1,
madam, 0 0.
0. And next
Q1
level
plus Q2 plus 0 0.
0, 0. Now see the clock signal 3. It is 0, 0. Then what is the value of D1 and D2?
Same, madam, 1 0 1 0.
Yes, 1, 0. Now see, after
Mm.
after the three na, the same things are repeated. So this
Correct,
is
correct.
called which mode? The mode number
3
in
mod
it.
3 counter.
Mod not 3.
Hmm.
So now how we will find out the output frequency? So hence after, so now we can write here, hence after 3 clock pulse, the output repeats, okay? So it is mode 3 counter, right? So output frequency,
12 by
just a
3.
minute, 12 by 3. Output frequency 12 by 3 equal
3,
to 4
4.
kilohertz.
Yeah, my option
Okay.
correct, but I have not given sufficient explanation. Correct.
Yes. So
Yes,
the right
now I
answer is
understand.
4
4.
kilohertz. Okay.
4 correct.
So can I move towards the next question?
Yes, yes, yes.
So this is the question number 5. Consider the D latch shown in the figure, which is transparent when its clock input CK is high and the zero propagation delay. In the figure, the clock signal CLK1 has a 50% duty cycle and CLK2 is one-fourth period delayed version of clock 1. The duty cycle at the output of the latch is percentage is the first option is 29 to 30%, the second option is 32 to 33%, and the third option is 27 to 28%, and the last option is 89 to 90%. So please try to solve the question. And there is no hurry, you take your time, but at least try. Consider the D latch shown in the figure, which is transparent when the clock output CK is high and has zero propagation delay. In the figure, the clock signal CLK1 has a 50% duty cycle and clock signal 2 is one-fourth period delayed version of the clock signal 1. Okay, so the duty cycle at the output of the latch is percentage is, so you have to find out the right answer.
Whenever clock is positive, it is a positive clock version. Whenever clock 2 will act as a high level, then followed the clock 1 at the Q1 madam, Q output madam. Maybe 29 to 30 percentage I will get T on minus T off by total T, like that we are taking duty cycle.
Okay, so let's find out the answer. Okay,
Yes, yes.
so first concept here, first write down the concept how to calculate this duty cycle. So the duty cycle of a waveform is defined as T1 by T, where T is the time period of the wavelength. Waveform, sorry. So now calculation part. So the output of a D latch is high when both input, that means the clock 1 and clock 2 are high. That is, the output waveform is AND gate, AND condition or AND gate condition of the two clock input. Now draw the clock segment. So when both input are high, then only the output will high in that condition. So it is satisfying the AND condition. Now we are going to draw the output. So from here you can see the clock 1. This is right. This is like that. And the clock 2. This is like that. So this is clock 1 and this is clock 2. Now tell me how the output look like. Tell me how the output look like.
Both are high, then only output high. Otherwise, any one of the clock 1 or clock 2 low level, output tends to low
Mm.
level.
It means here only it is up to this, it is high, right? Then it is up to that, it is also high up to this. Then you can also draw this. So up to this is called T clock, right? Now we just have to find out the T1 by T clock. So what is the value of T1 from here? Tell me how you will find out the value of T1.
T minus T clock by 5, madam.
Okay. Can we write down here the
Uh,
because this is like up to this now. This is T
yes,
clock.
yes.
So
T
this
clock.
is up to this is T half, right? T by
Yes, yes.
half.
Yes.
Up to this is T by T clock by half, and also given that portion, na, it is T clock by 5.
Yes, yes.
So
Yes, yes.
up to this is T clock by 2, and
Hmm.
also this is T clock by 5. So T clock by 2 minus T clock by 5. Can we write down T1 equal to T clock by 2 minus T clock by 5?
Yes, ma'am. Yes, ma'am.
Yes. Now calculate it. 10 by 5 T clock minus 2 T clock. Okay. So what is the value of it? 3 T clock by 10. So T1 is equal to 3 T clock by 10. Then the duty cycle will be the ratio of the one time with the time period. That is duty cycle equal to 3 T clock by 10 by T clock into 100
33%.
into 100. It's mean
33%.
33. Okay, you just calculate and
Madam,
33% means
even
about
any waveform like this T clock by 2 minus that particular T clock by 5 he is given. Somewhere maybe T clock by 3. Can we write like that?
sorry, I did not get you. Actually, just
Uh,
I have calculated like up to this now. This is the T clock.
oh,
Okay.
yes, yes,
So
yes.
just I have taken this is the T by 2 T clock by 2, right?
I
Then
understand.
here it is given this T clock by 5. So total is T clock by 2 minus T clock by 5. I have
Yeah,
done this.
understand. Correct,
Okay.
correct. I'll check it, madam. I'll check it. Thank you.
Okay. And the output signal like that. Up to this, only the portion, the both is high. Then here, only this portion. So up to this, like so from
E-
here to here, total is T clock. So
Yes,
this is the half, right? Up to this is the half, T by 2.
yes,
And
ma'am.
this portion is given T by 5. So T by 2 minus T by 5. So you can find out that portion. Okay,
Correct.
T1. Yes. So what will be the right answer? Actually, this is
33%. 30.
coming, I think I've not calculated, but the first option is the right option.
Yeah, I told that only, but when you calculated it is giving 33%. I
3,
told 29 to 30 only, but you are saying 33 percentage while calculation.
uh, how it is, just a minute.
Mm,
Just simplify it. T
yes.
clock by 10
Mm,
by T clock, so you can write down 1 by T clock, right?
correct.
Into 100. Sorry, this is 100. So
Yes, yes,
0, 0 cancel out.
yes.
So T clock, then 3 into 10, na? So
Yeah,
30.
30, 30, 30. Correct,
This
madam.
is
Correct.
not 33, this is 30. So the right answer is 29 to 30%.
Correct, madam. Correct.
Okay. So the question number 6, derive the Boolean expression for the logic circuit shown in the below. So I think this is the easy question.
Yes,
We
yes,
can
madam. We
find
can do.
out
We
the
will do, madam.
right answer.
A plus B into CDE, madam.
Okay. So tell me here, what is coming here?
A plus B into CDE. Answer. My final answer.
Then here it is coming A plus B into C.
Hmm.
Then it is coming A plus B. If we write here C, then the B will multiply with it. And next C into A plus B into D into E. The right answer, if it is defined by F, it is C into A plus B into D into E. Okay. So this is the question number 7. Statement. An ideal clock signal cannot be achieved because of the variety of process and environmental variation. So is the given statement is true or false?
True, madam. True, madam.
Yes.
Why? Because yeah, practical clock there will be some rise time and fall time, madam. So definitely answer is true, madam.
Yes. So this is the question number 8. How many gates would be required to implement the following Boolean expression before simplification? Xy plus x into x plus z plus y into z plus x plus z. So how many gates would be required to implement the following Boolean expression before simplification?
Yeah, 1 minute, madam. 6, madam. 6.
No, take it carefully.
No, madam. XY one gate, X plus Z one gate, X plus Z. Oh, 5, madam. 5, madam. 5. Mm.
Yes, because it is not given, it is two input or three input, na? So x and y, you can write here. And now at first x into y. So we can use the AND gate, right? There's xy
Yes,
is
yes.
coming here. Then x into x plus z. So x, okay, and z. This is OR gate. So here x plus z is coming, and then you have to multiply with x, again x. So from here to here, multiply, it is AND gate. So you are getting x into x plus z, right? And one more thing, y into x plus z. So here you can take like from, so this will be the y into x plus z. Now this is plus plus OR gate. So three input OR gate. Then what will be the output? X into y plus x into x plus z plus y into x plus z. So how many gates are required?
5, 5.
Five. One, two, three, four, five. The right answer is five. So this is the question 9. Dash is caused by static path length mismatches in the clock load by definition. Skew is constant from the cycle to cycle. First option is the clock skew. Second option is the jitter. Third option is the synchronization. Fourth option is the none of the above.
Jitter, madam. Jitter.
Uh, you recheck the answer. Okay.
Okay.
The answer will be
Maybe
the
clock
clock
skew.
skew. Yeah, you can recheck the answer.
Yes.
So this is the question 10. So
Madam,
consider the following circuit.
madam, previous things, can you define these terms clock, skew, jitter, and synchronization, if possible, if possible. Otherwise, I'll check it now.
You can check it.
Yes, yes,
Actually, from the
yes,
definition of where its definition is given, from there
yes,
you can directly got the answer. You
yeah,
can
yes,
also read
yes,
it.
yes, yes.
Consider the following circuit, the function by the network above. So you have to find out the output. Question 10.
We will do it, madam. No. Okay.
After simplification, tell me the answer. So what is the right answer? Am I audible?
Madam, I am not doing. My kids are playing. Parallel, I am listening.
Okay.
For this question, for this question.
So you were trying, or I had to solve?
Madam, I will check it, madam. No issue. Only tell me
Okay.
the answer. That's all.
Okay. So tell me what is the output here?
It is an OR gate, na?
Mm, NAND gate, no? What is the output of this NAND gate? A into B bar, right? So from here, E is coming, which is going through the AND gate. So what is the output here?
AB
A
bar
into
into
B
E.
bar into E. Okay. And here E and F, it is passing through an AND gate. So what is coming here? E into F, right? And here C and D is coming out from a NOR gate. So C plus D bar. And then F is coming here and it is passing through an AND gate. So what is coming here? C plus D bar into F, right? Then these three things are passing through a NOR gate.
Yes, adding and
So
bar, total bar.
yes, so add then total bar. So A B bar into E plus E into F plus C plus D bar into F, then total bar. Now simplify it and then tell me the answer. From here we can start. So how we will simplify it?
De Morgan's law.
Hmm, okay, let's start to simplify. Can we write down like at first this every plus now we can write here A B bar into E dot plus is re- replaced by this dot, then E into F. Then plus is replaced by this dot, and it is coming C plus D whole bar into F. Now more simplify it. What is coming here? Both bar A into B plus E bar. Okay, plus dot. If we simplify it, E bar plus F bar. Okay, then dot. Then if we simplify it, double bar C plus D plus F bar. This is F. This is F bar. So we can write down A into B plus E bar into E bar plus F bar into C plus D plus F bar. Right? Now more simplify it. You just multiply that one. You just multiply it. A into B into E bar. Just a minute. Into E bar plus A into B into F bar. This is F bar. Then E bar into E bar. What is the value of E bar if we multiply it with E bar? Hello. This is coming out E bar and plus E bar into F bar, right? And here C into D plus F bar is present. So just take common of this E bar. So what we'll get 1 plus ABF bar. Okay. And here 1, here F bar is coming plus ABF bar. Okay. And then C plus D plus F bar. Okay. So 1 plus something in Boolean function, it is coming 1. Okay. So here E bar plus A into B into F bar, right? And C plus D plus F bar. So this is the right answer. Are you getting the answer? Hello.
Yeah, okay, ma'am. Okay, ma'am.
So it is matched with your answer.
I have not done properly, madam, but I'll check it. I have confidence to do this. Parallelly, I'm doing some other activity. Okay, ma'am. No issue.
Okay. Okay. So this is a very basic question. I think this is a very easiest question. So how many gate would be required to implement the following Boolean expression after simplification? So the previous question was before the simplification, you have to find out how many gates are required. But here you have to find out how many gates would be required to implement the following Boolean expression after the simplification. At first simplify it and then tell me how many gates are required.
Three, madam. Three.
See carefully. No, 3 is not the right answer. At first, simplify it and then try to solve the answer.
Four, madam.
Take your time.
Madam, not required any gate, madam. One, not required any. Only one is the output.
Can you explain how you have calculated?
Xy plus x into x,
Mm,
that is 1, plus
mm,
xz plus yx plus yz. 1 plus anything is 1. That's why. Zero gates required.
Nazma, how many gates are required for this case?
Oh,
One second,
zero
ma'am.
gates. Only output 1, we will get the answer. After simplification, we will get 1, madam. Xy plus x into x plus xz plus yx plus yz. Xx is 1. 1 plus any Boolean function is 1. That's
Okay. Nazma, what is the right answer? After
uh,
simplification, how
one
many
one
gates are
gate, one
required?
gate, one gate. One. Even that also not required. After simplification, we will get only answer is 1 after simplification of Boolean expression.
Two gates, ma'am.
Can you little bit explain?
If we explain, we will have xy plus xz plus
Mm,
xy plus
mm,
yz.
mm,
So here xy we can write as xy
mm,
plus if we take out x common 1 plus z is 1
Hmm.
So x is remaining plus yz. Again here if we take x common, 1 plus y is 1,
Hmm.
x plus yz. So to implement this we require a AND operation between y and z and OR operation between
Hmm.
x and z.
So xy, you can write down the xy, then x, right, plus xz plus yz. So from there we can take common x. So what we will get? 1 plus y plus z, right? Plus y into z. So 1 plus something is equal to 1. So x plus y into z. So how we will represent it? This is x, okay? And if we are taking y and z, so the AND gate, right? And this is the plus. So also the OR gate is required. So now we can get x plus y into z. So how many gates are required? Only two, right? So next move over the question number 12. So applying De Morgan's theorem to the expression w plus x plus y into z whole bar, we get. So please simplify it.
What type of answer we have to provide, ma'am?
You just have to simplify it. The w plus x plus y, na? It is multiplied with z then whole bar. Then how you can simplify it?
W bar into x bar into y bar plus z bar.
Yes. W bar if we into x bar into y bar and it is plus, right? This whole thing is plus by the z bar. Yes, this is the right answer. So this is the question number 13. Simplification of the Boolean expression a into b plus a plus b a b c plus a b c d then a b c d e and then plus a b c d e f yield which of the following result? So just simplify it and then tell me what is the right answer. And in that case also how many gates are required? Simplify it and tell me how many gates are required to satisfy this expression.
One gate, ma'am.
Okay. And what is the output?
AB, ma'am.
Okay. Pradeep, you have seen that question answer? How many gates required in that case? How you have
Yeah.
represented?
Assessment. Two, three gates required. Three gates required.
No, only two gates are required. See it
X
carefully.
plus Y Z. Okay. Okay, madam. I will do it, madam. I'll do it, madam. No problem.
Okay. And then we have gone through this question, the question number 12. Just we have to simplify it, how we will represent it. Okay.
Yes, madam.
And then the next question. Just we have to simplify it and tell me how many gates are required in that case also. And what will be the
Okay.
output. So tell me how many gates are required in that case and what is the output. Nazma already given the answer.
Only one gate required, madam. One gate required.
Okay. So just take common AB. So 1 plus
Yes, yes.
C plus CD plus CDE, then
Yeah, two
CDE
input and
and
gate.
N.
Two input and gate required
So
enough.
AB. So this is 1. Okay. So it is A into B. So two
Madam,
input
but
AND gate is
as per syllabus, these digitals are not covered in the curriculum, madam. I think SAR is covered entirely IC design, madam. Entirely IC design.
But I have seen in the syllabus also there are some portion of this
Yes, madam. But
combination circuit and the sequential circuit and the like the logical gates, right?
SAR was not followed this time, madam. Earlier, the syllabus, that is a rerun course, microelectronic devices. But
Okay.
in rerun course, week 11 and week 12, SAR is describing with respect to the digital IC design, IC level SAR described, madam. But in previous lectures, everything will be described in terms of the logical design, madam, digital logic design.
Yes, yes.
Okay,
Actually,
madam.
I have seen
Mhm.
in the previous, I think the previous syllabus. So
Correct,
here also
correct.
mentioned a logical gate, combinational circuit, sequential circuit. That's why I have taken some of the question from there. So your basic
Yes, ma'am.
also you can clear here.
Yes, yes.
And also the question is also I have selected, so now I cannot change. So in first
Yes, yes.
you have also seen that some of the question are from the flip-flop like and the combination circuit. So okay, solve this.
Yes, yes.
The question number 14, the logic function implemented in the following figure. So you have to find out the output.
NAND, man. NAND. End, man. End gate.
So what will the output? And
AB.
get
Output
okay.
is the AB. Output is the
Okay.
AB.
Nazma, can you explain it how it is coming the AV? Nazma,
Ayyo.
can you explain it?
Yes, ma'am. The first NOR gate output is A bar. Below we'll have again B bar. So if we
Hmm.
give A bar and B bar to one more NOR gate, we'll have A bar plus B bar whole bar. By using De
Hmm.
Morgan's law, we'll have AB bar whole bar. So bar bar will be cancelled, we'll get AB.
So here you are getting A bar and B bar. Then it is passing through a NOR gate. Hold on. So it is we are getting A into B. So this is the question number 15. The symbol for two input OR gate in negative logic is. So see the option carefully and try to give the right answer. The symbol for two input OR gate in negative logic.
Option 3, madam. NAND gate. A bar and B bar is given to the NAND gate. So A bar, B bar, whole bar. Then it will be A plus B, madam.
Okay. Nazma,
Yes, ma'am.
what is the right answer? And can you please explain?
Implemented OR will be equal to NAND gate, ma'am.
So which option is the
Complemented inputs of OR is equal to NAND, ma'am.
here? See the question carefully. The symbol for two input OR gates in negative logic. So in first case, tell me what is the output if it is A and B.
A plus B.
No more. It will be A bar plus B bar.
No, no,
It
no.
is
Madam
simply
asking, no, no. Madam asking for individual what are the answers. Then
yes, yes.
you matching to
You
the
can
first.
match with the option.
Okay.
Yes,
Okay.
right?
Mine is A
Then
plus
tell me here what is coming.
A bar plus B bar whole bar.
AB. AB you will get.
Hmm.
A bar plus B bar, then whole bar. So it is coming A into B. And for the third case, what is
A
coming
plus B.
here?
A plus B.
A plus B. And for the fourth case,
A
A
bar,
bar
B bar.
into B bar.
A bar multiplied by B bar.
yes.
Two options are matching, but answer asking for the
But
two input
negative
target
logic, no?
native logic. Hmm.
Yes, that's why the answer is
Third option.
so option 3. So this is the question number 16. The output of the logic gate in figure is.
Option 3, madam.
Can you explain?
No, no, madam. 1 minute, 1 minute. A bar, B bar. So plus AB. Uh, Answer is option 3, madam. Exclusive or output is A bar, B bar plus AB.
Mm,
So option 3 is the
yes.
answer.
Nazma, what is the right answer?
A bar, ma'am.
Yes. So how it is coming? Just this is the XNOR, right? So output will be A bar B bar plus A into B. So here one of them is grounded, so you can consider it 0. So it is coming A bar. So the combination of two half adder circuit is
Full
A
ladder,
full adder,
full
ma'am.
ladder.
so
A
what is
full
the
Full
adder.
correct
ladder,
answer?
full ladder.
Okay. So here we are going to discuss about the full adder and the half adder circuit. Can you explain about the half adder and what is coming, the sum and carry, and how it is represent?
If AB are
Yes,
the
ma'am.
inputs, carry and carry is the A multiplied by B, AB, and sum is A exclusive or B. Full ladder means combination of three inputs, and sum is A exclusive or B exclusive or C, and carry is AB plus BC plus CA. Madam.
Yes, ma'am.
Sorry, this is A XOR B, right? This is sum. And what is the carry here? How you will represent by which gate?
And gate.
And
AB.
it is AB. This is carry. Just we are checking the basic of this half adder and the full adder. And now tell me the truth table. If it is 0, 0, then what will be the sum and what will be the carry for half adder circuit?
0 0.
Okay. And if it is 0, 1, then what
1
will be
0.
the sum? 1, 0. And for 1, 0,
1 0.
1, 0. And for 1, 1,
0 1.
0, 1. Now we are going to the full adder circuit. So how we will represent the full adder circuit? Tell me.
A XOR B XOR C, ma'am. With the three inputs.
And if the input is taking the C in and then A and B, now tell me how by the circuit you will draw the uh, full adder circuit.
First, take half adder between A and B. Take the
Mhm.
output of sum and XOR with CI to get the total sum output.
Yes. So first the half adder. So this is the half order, and then from there it is going to the XOR circuit. This is A XOR B XOR C in, right? This is the sum. And from there also an AND gate is coming. And the value is A XOR B into C in. So from here
Again,
we can see also the two half adder is forming the one full adder, which was our question. And here and from here it is connected with which gate?
OR gate, ma'am.
OR gate. So this is the carry output. This is OR. And what is the truth table for it?
Sum is 1247, ma'am. Carry is 3567.
Uh, like A, B, C input, and then sum, then C output. If it is 0, 0, 0, what is coming? Sum and C output
00.
0, 0. And if it is 0, 0, 1, then what will coming out from here?
10.
1, 0. And if it is 0, 1, 0, then
0.
1, 0. And if it is 0, 1, 1,
01.
0, 1, and then I
For
think
1
1,
0
0, 0,
0.
right?
1
1,
0
0, 0
0.
is coming
1
1, 0.
0.
And then 1,
1
0,
0
1 is 1,
0
0, 1,
1.
0, 1. And this is 1, 1, 0. This is
0 1.
0, 1. And this is 1, 1, 1. This,
1 1.
yes. So moving towards the next question, question number 18. Dash are an example of the combination circuit. First option is the shift register. Second option is the multiplexer. Third option is the counter. And the fourth option is the flip-flop.
Multiplexers, ma'am.
Yes. So the next question is which of the following circuit has its output dependent only upon the present input? So which option is the right answer?
Combinational circuits.
Yes. So next question is how many input terminal is represented by T flip-flop?
One input.
Yes. Actually, this is the previous question. Today I have said this 20 question. So those who have completed this, you can leave, and those who joined late, na, they can solve some question here. Nazma, I think you have joined late, so you
Yes, ma'am.
can continue it, and other student, you can. So please try to solve this two, three important question. Then, because I have only said this 20 question. So Najma, you can try to solve this question.
Okay, ma'am.
And you please try, and I am coming back in 1 minute.
Okay, ma'am. Sure, ma'am.
Hello. Now
Yes,
tell me
ma'am.
what is the right answer.
Ma'am, I don't have correct idea, ma'am, on this question.
You have to find out how many modes are there, and then you have to find out the output frequency from it. See, uh, this is Q1 and Q2. This is D1 and D2. Okay, and this
Yes,
is
ma'am.
the next stage. This Q1 plus, we can write down the next stage, and this is the Q2 plus. Okay, to see. In the first stage, we are considering the clock is 0. In that case, the Q1, Q2, we are taking 0, 0. Now tell me what is the value of the D1 and D2. See, Q2 bar is going to the AND gate with Q1 bar. Okay,
Yes,
and then
ma'am.
it is going to the D1. So D1 is equal to the
One.
AND connection of the Q1 bar into and the Q2 bar. So now tell me what is the value of D1 if Q1 and Q2 is 0, 0.
D1 is 1.
Okay, and what is the value of D2? See where from where the D2 is coming. Directly from the Q1 the D2 is coming. Then what is the value of D2 if Q1
0.
and Q2 is 0, 0?
D2 is 0.
Okay. And for the D flip-flop, if the input is 0, then what is the
0, ma'am. Output is
output?
0.
Next stage output. Output also 0. And if it is 1, then what is the next stage output?
1, ma'am. 1, ma'am.
1. Yes, good. So if D1 is 1 and D2 is 0, then what is the value of the Q1 plus and Q2 plus?
Same, ma'am. 1, 0.
1, 0. So it is the next stage. So this next stage is coming to the clock 1.
Yes, ma'am.
So what is the value of Q1 and Q2 here? Then it is 1, 0. Now tell me what is the value of D1 and D2?
D1 is 0.
Hmm.
D2 is 1, ma'am.
And what is the next stage?
0, 1.
0, 1. And this is coming in the clock 3,
Yes, ma'am.
which is 0, 1. Now tell me what is the value of D1 and D2?
0,
0.
0, ma'am.
Hmm. Then what is the next stage?
0, 0.
0, 0. So it is coming to the clock.
4.
Sorry, this is 0, 1, this is 2, this is 3.
Okay, ma'am.
So it is coming to the 0, 0. Next, what is the value of D1 and D2?
1, 0, 1, 0.
Yes. So see, after the three, now first z- one, two, and three, the same thing is repeated, na?
Yes, ma'am.
So this is called the mode three. After three, it is repeated. So we can write down here. Hence, after 3 clock pulses, the output repeats. Okay.
Yes,
So
ma'am.
it is mode three. Okay. Mode three counter.
Mm.
So for mode 3 counter, how you will find out the output frequency? So output frequency is the output frequency is 12 hertz by mode, number of mode. So equal to 4 kilohertz.
4 kilohertz.
So this is the way you have to find out the output frequency.
Okay, ma'am.
Now it is clear?
Yes, ma'am. Clear, ma'am.
Yes. Okay. So there is one more important question. This is the question number 5. Consider the D-latch shown in the figure, which is transparent when the clock output CK is high and has zero propagation delay. In the figure, the clock signal CLK1 has a 50% duty cycle, and clock 2 is one-fourth period delayed version of the clock 1. So the duty cycle at output of the latch in percentage is. So see the circuit carefully, the clock 1 and clock 2, then find out the output for delatch circuit. And then tell me what is the latch percentage here. So first option is to 29 to 30%. Second option is 32 to 33. Third option is 27 to 28. And the last option is 89 to 90%.
Duty cycle is T on by T total, ma'am.
Yes, yes.
Clock
T1
2,
by
ma'am.
T clock.
T on
So
by T
you
clock.
have to find, at first you have to find out the T1. Clock,
Yes.
both clock are given, you have to find out the T clock. Sorry, T1.
So 50% duty cycle means exactly half will be on, the other part will be off, ma'am, for clock 1.
Mhm.
Clock 2 will be delayed by 1 by 4th period. So after 1 by 4th delay, the clock 2 will start. So the
See,
total
here the clock 1 and clock 2 already given. From this circuit, you can find out the clock 1 and clock 2 given. Just this is already given here, how it is look like. Okay, you just have to find out the output clock. Just output you have to find out. And there is a one more point that for the D latch, when the both clock are on, na, both in on condition, only the output is 1. Then only the output is 1. So now you can draw the output from here. When the both is 1, in that condition, the output is 1 and remaining are 0. Now can you simplify it? Clock 1 is given, clock 2 is given. When clock 1 and 2 both are on, in that condition, the output is 1. Now draw the output clock. Actually, these two questions are very much important. And other question you can easily solve the Boolean function and some of the combinational circuit. So we can go through the video lecture also, or you can go through the PPT so you can easily solve. Now tell me the clock 1 and 2 given. So what is the output clock? What will be the output? For the simplification, we can draw here
the on condition will exist from T by 2 minus T by 4 duration, ma'am.
T by 4. See, it is delayed. The T1 condition, it is delayed. Here it is already given. T clock by 5.
But the you see, ma'am, there in the question they have given the clock 2 is 1 by 4th period delayed version of clock 1.
They are actually considering from here. At first, you should draw it. So from the circuit, you can see, just see it from here. This is the, and this is clock 1, and this is clock 2. Clock 2 is coming that portion, then this portion, then this one, this, and this. Okay, so they are considering maybe they are considering from the this portion. But now tell me for the output how the structure look like, the pulses look like. When both are in one condition, then only it will one. So up to this is zero, and only that portion is one, right?
Yes, ma'am. After that, again 0.
Again zero zero. Then from here it is coming one, and this portion is zero. Now, if we are considering from here, now tell me from up to where it is coming, the same cycle is repeated. We are considering from this portion. Here it is from here it is repeated, like right? So now we can consider this portion is T clock. Can we write down it is T clock?
Yes, ma'am.
Yes, from if we are taking from here, it's there, so you can see from here it is also repeated. So this total is T clock. Okay. And now
Yes.
tell me what is the value of this T1? This total is T clock, right? From here to here, this is T clock. Then what is the value of this portion? Now tell me what is the value of T1? So here to here it is T clock. Then what is the value of this? And also it is given, like see, this portion. It means this one and this one. Here this portion is T clock by 5. Now tell me what is the value of this only this T1 condition. How you will find out?
Ma'am, uh, uh, as already mentioned, clock 1 is 50% duty cycle means on is 50%, off is 50%, ma'am.
Hmm.
If I consider the clock total time as T clock, on
Hmm.
duration is T by 2, off duration
Hmm.
is T by 2.
See,
So as it
from
is
from see from here now, as you told, the 50% is positive and 50% is negative. Just
negative.
consider it. So this
Yes,
is
ma'am.
T by 2, right? So
Yes,
this
ma'am.
total portion is T by 2. Here to
Yes, ma'am.
here, T by 2.
T by 2.
So
The
if
on
T by
duration is
2
minus T by
minus,
2.
now here you can see this is T by 5, right?
5.
This
Yes,
portion
ma'am.
is T by 5. So minus T by 5 or T clock by 5.
That is the on time, ma'am.
This is the one time. So just simplify it and tell me the answer.
0.3, ma'am.
Mhm. Okay. So
30%.
you can write down 3 by 10 into T clock. Okay. So
Yes.
now tell me what is the value of the duty cycle.
T on by T clock, ma'am. T
Yes.
clock will be cancelled, no, ma'am.
T by 3 by 10, T clock by T clock. And you have to find out in the term of percentage, like into 100%. Now
100.
tell me what is the value of this
30%, ma'am.
30%. So which one is the right option?
29 to 30.
Yes.
Ma'am,
Okay, the Nazma up to
I
yes.
have one doubt, ma'am. In the question, they have mentioned that 1 by 4th period delayed by the clock 2 is delayed by 1 by 4th, they have mentioned, no, ma'am. But in the diagram, they have
Mm.
shown it is clock by 5.
So yes, so maybe there is a mistake here.
Yes, ma'am.
1 by
Okay.
5th period, I think it will be. Because
Yes.
here it is in the diagram it is shown T clock by 5. It is delayed, right? So
Yes, ma'am.
maybe there is a printing mistake.
Sure,
Okay?
ma'am. Yes, ma'am.
Okay. Okay. Now you can leave.
Ma'am, uh, uh, I have a question, ma'am. So I just want to need what are the important topics, ma'am, in the syllabus?
I think the syllabus is already given. I cannot directly say na. You have to go through some of the see the main things. The all the TA there are two TAs. They have uploaded the PPT. If you have short time na, just go through the PPT. The multiple question they have solved. Just
Yes, ma'am.
see how they solve the question and the answer. If you have less time, and if you have enough time, you can go through the lecture video also. So I think if you solve this type of question now, so it will help in your exam also. Because whichever part so sir already given in the syllabus, so we are following this type of just taking some of the question to solve this type of cover this type of syllabus.
Okay. Ma'am, where we can get the total syllabus, ma'am?
It is
In
not
microelectronics course phase, about course it is mentioned week 1, week 2, week 3, week 4,
yes,
week
I
5
think
it is
they
there.
have mentioned in the course now in the left side. I think they have mentioned where the video is uploaded.
Okay, ma'am.
Even in that
Yes.
course page, on the top of that, rightmost announcement, course outline, about the course, ask a question, course progress, mentor. At that place, one by one tab is giving all the details, madam.
Yes. So my suggestion is at least go through the question which this both TA are solved. Na? Go through the
Okay,
question
ma'am.
and see the syllabus. If you have and if you have enough time, then you can go through the lecture videos.
Sure, ma'am.
Okay.
Thanks, ma'am. Thanks for your
Oh,
suggestions, ma'am.
Yeah.
okay.
Thank you, ma'am. Arpita, ma'am. Thank you.
Okay.
Mm,
Okay.
maybe this is the last
Lecture.
Yes.
this.
For this session, this is the last class. Then next session we will take the another class. And also in previous session, I have taken the fabrication related, I think sensor and actuator class.
Oh, fine, fine. Hardik J.
Mm.
Pandya, sir.
Yes, yes, yes. The Professor Hardik Pandya.
Yes, ma'am. I myself completed 15 courses NPTEL. I know.
Wow, that's great. And also, I have seen two, three students, including you,
Yes,
regularly
ma'am.
join this class. So I'm really, and also I am a student, and you already know that. So,
Yes,
sir,
yes.
you're from faculty
Yeah,
background, like?
yes, ma'am. Faculty from Anits Engineering College, Vishakhapatnam, madam. Vishakhapatnam.
Okay, okay.
Vishakhapatnam.
So
I am
actually, this
interested.
is
I
all.
am interested. Yes, yes. Tell me, ma'am. Tell me.
So you were working on the fabrication field or the circuit
Yeah, yes,
field?
ma'am. Hardware security, FPGA related. I am working on with respect to. I am presently working for the circuit trojans. I'm trying for that. Yes, ma'am.
Okay, okay. Actually, I'm just working on the fabrication field, and directly after the MTech, I have joined in the PhD. So
Yes.
this is also a learning session for me also.
Yes, yes, ma'am. Yes, ma'am. Even I asked for how to find and the time constants. You worked a lot,
Mm,
madam. I got the correct answer. Even
thank you.
parallelly, I am working for. I am very well with respect to the theory of feedback amplifiers. Now, after these sessions with respect to circuit orientation, also I am good at feedback, different circuits, topologies, and all the things.
Yes, actually, we are also learning many things from the you because
Yes, yes, yes,
as you know that we are also students and we are learning.
yes, ma'am. Yes, ma'am. Thank
So
you.
actually, we have so many options there also. We can take from the nearby college. We can go nearby school also. But I have decided to take this NPTEL course, so I can also learn from. I can interact with these type of people, and I can learn from them
Yes, yes,
also.
ma'am. Even
Okay.
I was a student of NAT Warangal, madam. Between 7 to 9, my PG was completed. Huh?
Okay.
At that time, only we were concentrating much on analog VLSC only, madam. That's why I'm
Hmm.
so interested about devices and theory and all
Okay. Actually, in my MTech also, I have worked on the simulation part of the devices, and now I am starting to fabricate the biosensor like the devices.
that. Yes.
So
MEMS, you are working
that
with MEMS, I think so.
no, it is not totally MEMS. Have you heard about the resistive devices?
Okay. Resistive
It is
device.
not total part of this MEMS fabrication, because in the MEMS fabrication lithography is also needed. But in my case, no, lithography is not necessary. But it
Okay.
is also part of this. So resistive device I am preparing for the biosensing purpose. So now I have just started. I have just completed the second year in
Oh,
PhD.
fine.
So next I'm also going to I and it is also mandatory for the PMRF students to take these classes.
Oh,
And not only the
okay.
NPTEL courses, they can according to their feasibility, they can choose the nearby school, college, and somewhere else also they can take. And there
Yes,
is
yes.
it is not bounded. Okay, so
Yes, sir.
it is just depends on our choice. So,
Yeah. Sharing education knowledge is a serving society,
yes,
madam.
because when we are sharing, na, in that case, we are also taking knowledge from them also.
Yeah,
So this is
correct,
a good
correct.
session.
Nice, madam.
Okay, okay, fine.
Fine,
So
madam.
Fine.
Fine.
if I'm also in the next session, if I'm taking some of the classes, so in that case, because we don't know which class we are going to get, so
Yes, yes,
okay,
madam.
Mm-hmm.
Understand.
let's see.
Yes,
Okay,
ma'am.
good.
Thank
Yes,
you,
ma'am.
madam. Thank you, madam.
Okay.
Yeah.
Bye, ma'am.
Okay, okay. Bye.
Bye, madam. Bye.